Right-click on the image result and copy the image. Then create a new workflow where we compare the two images. I press Ctrl+V to paste the image, and you will see it adds a load image node with that pasted image. I do the same for the image from the second workflow. Now we have both results. Let us add an image comparer node so we can compare them. Connect the first image to image A and the second image to image B, then run the workflow. Now we can enlarge and compare them. The results are quite similar, but still slightly different. This happens because I used a text encoder that is different from the one included in the all-in-one workflow. If I had used the same text encoder, the results would have been much more similar. Let us try again with a different prompt. Maybe we do a portrait photo of an old woman. We get a result like this one. Now let us do the same for the second workflow, and we get another woman for this one. Let us copy both images and go to the comparer workflow. Select the Load Image node and use Ctrl+V to paste the image into that node. Now we can compare the two results. Again, because the text encoder is different, the comparison is a bit harder. Still, I kind of like the FP8 scaled version more. You can see that we use the same settings for both workflows. One has everything included, and the other has everything separated. If I searched for the same clip used in the AIO workflow, I could get much closer results. This load clip node is something we will use in other workflows as well. As you can see, it has a type option that lets you select different types of models to match the diffusion model you loaded. Do not stress too much if you do not understand everything yet. It will make more sense as you practice. If we look at the VAE, you can see where it goes. As you remember, we use it to connect to nodes like VAE decode and VAE encode. If we go back to the first workflow, that VAE is coming directly from the one included with the main model. Different model formats do not change what an AI knows. They only change how that knowledge is stored. So choosing the right format is about balancing quality, speed, memory, and flexibility for your hardware and workflow. GGUF stands for GPT Generated Unified Format, and it is a model format designed to run large models efficiently on systems with limited memory. In ComfyUI, let us go to Workflows again, and this time open Workflow 5B and 5C so we can compare them. The workflow we saw in the previous chapter had three nodes: Load Diffusion Model, Load Clip, and Load VAE. And you can see that it was loading safetensors files. If we go to the GGUF workflow, you can see that some nodes are different. We now have a UNet loader that has GGUF in the name, and the file format is GGUF instead of safetensors. We use this node to load GGUF type diffusion models. For the clip, we could have used the previous node to load an existing text encoder, but I wanted to show that you can also use a clip loader GGUF node to load text encoders in GGUF format. The last node is the same load VAE as before. So compared to the previous workflow, we only changed two nodes so we can load GGUF models, but we do not have those models yet. So let us go to the notes and check which node loads which model, and also look at the download links. If we go here, you can see there are many GGUF model versions. Most of the time, you will see something with a Q version in the name, like Q2, Q4, Q6, or Q8. Most of the time I use Q8 models. If that is too big, I switch to Q6, and if that is still too big, I use Q4. The lower the Q number, the lower the quality of the generation, but the models are smaller and can be faster on limited hardware. Let us look at what this model name means. Z-Image Turbo. This is the core model family and variant name. Q4. This means the model is quantized to 4 bits precision. Lower bit quantization reduces file size and VRAM usage. The K indicates a specific quantization method, usually a block-based or K-quant method, which helps preserve model accuracy even at low bit precision. The S usually means small or standard variant within that quantization type. It trades a bit more quality for a smaller footprint compared to M versions, which stand for medium. GGUF. This is the file format. Let us download this model and give it a try. We go to the ComfyUI folder, then to the Models folder. This main model, just like in the previous workflow, goes into the Diffusion Models folder. Since we already have the Z image folder from the previous chapter, I will place it in the same folder because it is the same base model, just a different quantization. So we save it there. Now let us do the same for the text encoder. We click here to download it, then again go to the Models folder, find the Text Encoders folder, and place the model there. For the VAE, if you followed the previous chapters, you should already have it. If not, download it and place it in the VAE folder. These models are big, so wait for them to finish downloading. After the download is finished, press the R key to refresh node definitions, so ComfyUI can see the new models. Now we go back to the nodes and make sure we can select the models. The Z image model is there. The text encoder is also there. I am using the one with gguf in the name because if you use a safe tensors version here, even if it does not give an error, the results will not be what you expect. For the VAE, we already have it. So now we have everything we need. Let us run the workflow. The result looks pretty good for a Q4 version. Let us open the bottom panel and run it again. You can see that the first time it loads the model, it is slower, but after that, it takes around 5 seconds to generate. In my case, this was slower than the all-in-one model or the FP8 scaled version. That does not mean it will be the same on your system. On some systems, it might be faster. That is why I keep saying you should test everything and then keep the best model for your setup. What is best for me will not necessarily be best for you, because we have different video cards, different VRAM amounts, and probably different drivers. Now I am curious how a larger Q version will perform. So let us go back to the model list. This time I want to test a bigger one. The biggest available here is Q8, which is around 7 GB in size. I have 24 GB of VRAM, so I can easily fit this model in memory, and even larger ones. Sometimes, if a model is larger than your available VRAM, it will be slower because it tries to load the model in parts. You lose time during that process, and generation can be slow or it can even crash ComfyUI and force you to restart it. So let us download this one. We place it in the Diffusion Models folder, inside the Z image folder, right next to the Q4 version. Again, wait for it to finish downloading. Luckily, I have a fast internet connection. After that, press R to refresh. So now, in the UNet loader, we can see both models. By the way, UNet is the main neural network inside a diffusion model that predicts what noise should be removed at each step to turn random noise into an image. First, let us change the seed to fixed so we can compare the models properly. I get this image for Q4. I copy the image, create a new workflow, and paste it there. I will rename the node to Q4 so I know which model was used. Now, let us go back to the workflow and select the Q8 model. Everything stays identical, only the model changes. Let us see what we get. It looks similar at first glance. I copy this image, go back to the new workflow, and paste it there as well. I rename this one to Q8. At first glance, the Q8 version seems to have fewer mistakes and looks clearer. Let us add an image comparer node to compare them properly. Connect the two load image nodes to the image comparer and run the workflow. The first image shown is image A, which is the Q4 version. As we move the cursor to the right, we see the Q8 version. In my opinion, Q8 has better details and fewer errors. For example, some bolts seem to be missing in the Q4 version, while the Q8 version looks more complete. In most cases, Q8 will be better than Q6 and better than Q4 in terms of quality. But now let us check the speed. The first time, Q8 took longer to load because it is a 7 GB model. Let us change the seed and try again. Now the second run takes under 4 seconds. Let us try once more. We change the seed again, and once more it takes under 4 seconds. Now let us switch back to the Q4 model. This one is lower quality, but also smaller. You can see that the first time it loads faster. Let us change the seed and try again. The second run takes more than 5 seconds. Let us try one more time, and again it takes more than 5 seconds. This is why I keep saying you should test all of them and then decide. For me, Q8 is faster and gives better quality than Q4, but that is because my video card probably works better with that quantization. On your system, especially if you have an older card, it might be the opposite, and Q4 could be faster. So please test them yourself, and then keep the one that gives you the best quality and the best speed on your system. So let's go to workflow again. And now it might make sense why I named Workflow 5 all these three workflows, because they are workflows for the same model, just different model types. So let's open Workflow 5a, and you will see how we can adapt the workflow. Let's move this to the side. So this has an all-in-one model with everything included. We want to change it into a workflow where the models are split. So let's start with the model. Instead of load checkpoint, we search for load diffusion model. This one only loads the model without clip and VAE. And we select the Z image model from the list. Then we need a node that has that clip output that loads the text encoder. So we search now for a node called load clip. Let's make it bigger so we can see the parameters. We first select the text encoder. Then we select the type. Z image uses Lumina 2. Lumina means light. You can think of it like reaching the end of a tunnel. Z is the last letter of the alphabet, and at the end, you see the light. Lumina 2 represents a newer, clearer way for the model to understand prompts and guide image generation. It simply means more advanced guidance compared to older models. Then what is left is the VAE, so we use the load VAE node, and we select that VAE model. So now all that's left to do is to redo the connections. We drag a link from model to model. Pretty easy, right? Now we need the clip, so let's drag another link. And all that's left is the VAE. This one will connect to the VAE decode node, and if the workflow is image to image, it will go to VAE encode also. Now we can get rid of the load checkpoint node. So now we successfully replaced all the models, and basically we have the workflow version 5b that we used before. So let's run it, and it all works okay as it should. Let's say the model we use now is too big and our video card doesn't have enough VRAM. Then we can try a GGUF model to see if it works faster or better. So let's search for a node again, and this time search for the UNet loader, the one that has GGUF in the name. So in this node we can select a GGUF model. You can see I downloaded two versions before. So let's say Q4 is smaller in size than the FP8 version in this case, so it has better chances to run faster than a bigger model. But as you saw before, on my computer, Q8 was faster, so maybe I will use that to get better quality instead. Let's connect the model, and now we can remove that node. So we replaced an FP8 Safe Tensors model with a GGUF version. And if we run this workflow, you can see it works just fine, and we got a nice result. If for some reason you are not happy with the text encoder, maybe it is not so accurate or it is too big, we can try a GGUF version of the text encoder also. So let's delete that node and let's search for cliploader, the GGUF version. You can see it has cliploader in one word. So now we can select the GGUF model. And of course, we need to adapt the type since it is not Stable Diffusion, it is Lumina 2 instead. Remember that light at the end of the tunnel. And then link the clip to text encode prompt. And basically now we have the workflow 5C. So you saw that having a modular version allows you to change models and have more freedom, just like on your computer. If you are not happy with a mouse or your printer, you can change it with a smarter or faster version. Now, if you do have enough VRAM, you can try to increase the size for width and height to get more details. For example, at this size, I got this image, and now we can see more details on those cables and overall. But usually for Z image, I use values between 10, 24, and 1280 pixels. So at the moment of this recording, Z image is a pretty good model to have. It is free, and you can generate all kinds of stuff with it. Let's compare a few of these models to see what the difference is. So for this one, I compared the FP8 all-in-one version with the FP16 all-in-one version, which is double the size. The results are quite similar. Maybe the FP8 is a little more desaturated compared to FP16, and FP16 might be a little bit clearer, but it is not a huge difference. Both are good quality. For the Viking image, the FP8 version has fewer details in some areas. In FP16, it added some extra things, like more ornaments. Again, FP8 looks a little more desaturated. For the bunny, both look good. So I would say if FP8 is faster, has half the size, and the results are very close, you can get away with FP8 and keep that. Now let's compare the FP8 version with the FP8 scaled version. Keep in mind that the text encoder is also different in this case compared to the one included in the first model, but the results are still quite similar. Sometimes FP8 does it better, sometimes the scaled version does it better, so if you do more tests, you can decide which one is better for you. Since the results are very close, again, it makes sense to keep the one that is faster on your system. Now let's compare the FP8 version with the GGUF version. Instead of the Q4 version, I will use the Q8 version downloaded from here so we can see the difference. For the portrait, it looks a little clearer on the Q8 version. For the Viking, some details are more defined on the Q8 version. For the bunny, it is pretty similar for me. For other models we will test in the future, the difference might be bigger and more obvious, but in this case, the difference is quite subtle. So which one will I keep for my video card? Maybe the FP8 scaled or the Q8 version, mainly because they are modular and I can save space and time when I use the same models for other workflows. In this chapter, we explore batch generation and styles. So let's open another workflow, this time workflow 5a, since it has fewer nodes and you can see things better, but the methods I show work with any workflow. Right now, each time you press the Run button, the workflow runs once and you get a single image. But what if you want more images and you do not want to click Run every time? In this node, we have an option for batch. By default, it is set to 1. You can change that, but keep in mind it will use more VRAM because it is like running multiple workflows at the same time. If your video card can handle it, it will be faster than generating one image at a time. So now we get 2 images. If I change it to 4 and run again, we get 4 images. If we toggle the bottom panel, we can see the time it took for 1 image, for 2 images, and for 4 images. If we multiply 3.77, which is the time for 1 generation, by 4, we get over 15 seconds. But because we used batch, it only took 13 seconds. So you need to see what batch size works best for your video card. I might be able to use a bigger batch, but you might need a smaller one. Now from these 4 images, we can click on any of them to open it bigger. These images are saved in the output folder as well. To close the big preview, you can use the X in the top right. Let's open another one. You can also navigate using the buttons in the bottom right corner, so you can check all generations. The bigger the image, the more VRAM it will need. Let's say I set the batch to 8, since the image size is quite small. The result is 8 images. You can check the results and pick your favorite. You can right-click on an image and save it in any folder you want. Now let's change the batch back to 1, so we only get 1 image. Next to Run, we have an arrow that shows multiple options. Here we also have batch count. This is not the same as the batch we used before. Think of this like a counter where you tell it how many times to run the workflow. So if I set the value to 4 and hit Run, it will run once, then again, and again, until it has run 4 times. This is a bit slower than the previous batch method, but it uses less VRAM. If we add these values, we get over 14 seconds. With the batch and empty latent, we got 13 seconds. You might say, 1 second is not much, but if you use bigger images and longer workflows, seconds can quickly turn into minutes. Let's change the batch back to 1, and let's explore more run options. Run on change will run the workflow when we change a value, so if I change the seed, it will start running. It should stop after the run, but I am not sure if this is a bug or if this is how it is supposed to work. Because the seed is random, it keeps generating continuously after the first change. But if the seed is fixed, it only runs the workflow when I make a change, and then it stops. So I will stop it manually by switching back to Run. If I change it to Run Instant, it will generate forever until you stop it. So do not forget to stop it by going to the arrow and selecting Run. After it finishes that workflow, it will stop. But what if we want to run multiple prompts? Until now, we only had one prompt, and the seed was different. But for the Z image model, for example, the seed variation is not that big compared to other models like Flux or Stable Diffusion. So let's search for a node called iTools Line Loader. This node loads each line as a prompt. If we drag a link from this line loader output and connect it to the text encoder, a small dot will appear in the top left corner of that text input. By default, you have 3 prompts here: cat, dog, and bunny. Let's say the first prompt is a cat photo, the second prompt is a bunny with a flower, and the third prompt is a lion logo. We have a seed here that decides which prompt will generate, and we also have control after generation. Randomize means that after each generation, the seed will change to a different random value. So let's run it. We got a cat, and now we have a different seed. For this seed, we got a bunny. Now let's change the seed to fixed, so we can understand better how this works. For the seed, we put 0. In computer programming, lists usually start with 0, not with 1. So instead of 1, 2, 3, it is 0, 1, and 2. So 0 corresponds to the cat prompt. If I run the workflow, I get a photo of a cat. If I change the seed to 1, it corresponds to the second prompt, which is the bunny, so the result is a bunny. And for seed 2, we get a lion logo. Now we know the order in which this node uses the prompts. Can you guess what we will get for seed 3? It will start over with the first prompt, so the result will be a cat photo. Let's add another prompt, like a rose, and maybe a house with a car in front. I will start with 0, so it starts with the first prompt. Then for control after generate, I will use increment, so it starts with the first prompt and continues with the next one, and so on. This way it is more controlled and not random. Now that we have 5 prompts, I can change the batch to 5, so it runs the workflow 5 times. You can see it will generate all those images, 1 prompt at a time, in order, and it will stop after 5 generations. You can also put 10 if you want to get 2 generations for each prompt, or you can let it run continuously and stop it when you get something you like. We saw how we can load prompts line by line, but we can also load prompts from a text file. Let's search for iTools Prompt Loader. As the name says, this node loads prompts from a file. Let's drag a link from it to the positive prompt. You can see here it says file path. We already have an example with a prompts.txt file, so let's run it. It will pick a random prompt from that file, and the result is this cat. Now let's find that prompt's text file. Let's go to the ComfyUI folder, then go to Custom Nodes, and here look for the ComfyUI iTools folder. These are all the files used by that node. Basically, the node itself looks like this. If we go to the Examples folder, we have a text file with prompts. Let's open it. You can see we have a few prompts here, and the image that was generated corresponds to one of these prompts. You can delete everything and add your own prompts here one by one, or you can ask ChatGPT to generate a bunch of prompts. So maybe I will add one for a dog, maybe one for a cat, and one for a rose. Now I can save that file and close it. Let's go back to ComfyUI and generate again. It should pick prompts from the same text file. Now we got that cat playing with a mouse. Let me remove this node and try again to see if we get another prompt. And now we got a rose. If the text file is in a different location, you just add the path to that file here so it knows where to load it from. And of course, you can change to run instant and let it run, then stop it when you have enough images generated. Let's delete this node and I will show you more things you can do. Let's search for a node called iTools Prompt Styler and select this one. This node picks prompts or art styles from a file. We have positive and negative prompts, but since our workflow only uses the positive prompt, we drag a link from there and connect it to the positive prompt input. Here we have an area where we can type our prompt. Let's say I type a white bunny holding a rose. Then we can select the style file. These files that contain different prompts are stored locally. Let's go to the Custom Nodes folder again, then to iTools, and this time go to Styles. You can see here a few example style files, which are actually YAML files. If we go to more examples, we have even more. Now, if we look back here at the file list, we can see exactly those files. Among them, there is one called Pixaroma. I asked the creator to add my file there so you can access it easily. Thanks, Makati. Once you have the file selected, you can choose a template from that file. You can see here different templates. For example, I can select a 3D icon or something else. What is important to remember is that you select the file first and then the template inside it. For example, let's open one of these files with Notepad so we can see what is inside. Each template looks like this. You have the template title, the negative prompt, and the positive prompt. As you saw in our workflow, we only use the positive prompt this time, so it will only pick that part. In the positive prompt, you can see the word prompt inside brackets. That is where it takes your prompt and combines it with the rest of the template prompt. So if I do not have anything selected here for the template, it will use something like landscape photography of the prompt. And instead of the word prompt, it will insert a white bunny holding a rose. Basically, we recreated what these styles do. This system saves you time by letting you write a short prompt and combine it with a ready-made prompt from a template. This was created back in the days for Stable Diffusion models, when we did not have access to AI prompt generators. It still works today with most models that recognize these prompts, even though you have much more freedom using a custom prompt made with ChatGPT. So if the prompt is a white bunny holding a rose, and for the file I select the Pixaroma file, then for the template I can filter by landscape and select photography landscape. Now when I run it, it should combine my bunny prompt with the landscape photography prompt. And the result is this one, so everything works quite nicely. Let's change the template. Let's say I select 3D icon and run the workflow, and we get this 3D icon of a bunny holding a rose. Now let's try an ancient Egyptian mural. We run it again, and we get this mural, and you can clearly see our bunny in the image. Let's say I select the Rococo art style. The result is this decorative style illustration of the bunny. Now let's open the Pixaroma styles file with Notepad. You can see all the templates and prompts for each style, and you can edit them if you want. Just keep the same format, otherwise it will not work. Let's say I want to use the template for Surreal Toy. If I use it in the workflow, it will take this prompt and replace the word prompt with my bunny holding a rose. So let's test it. From the templates, I search for Surreal and select that toy style. Now let's run the workflow, and we get this 3D surreal bunny with a rose. Pretty cool. Let's scroll down and see what else we can use. Let's say Afrofuturism art. That means it will use that specific prompt. Let's change the style and test it. And the result is this one. Keep in mind, each model will interpret these prompts differently depending on how it was trained. There are over 300 styles or prompts saved in this file, from 3D to art styles, painting, photography, design, all kinds that I use most often. Let's say I select the vector coloring book page style. Now when I run it, I get this clean coloring page design.